Okay, welcome back everyone. Lesson 6, Exponents and Order of Operations. This is a really important lesson. This is where the game begins, so to speak. We have to master order of operations or algebra is just not going to be possible. So let's dive in. Some reminders. Some of you may have seen this before. Some of you maybe not. An exponent is a shorthand notation for repeated multiplication. So, 3 times 3 times 3 times 3 can be expressed as 3 to the 4th power. So the 4 is a superscript, right? That's your exponent, and 3 is called your base. We read this as 3 to the 4th power. So the exponent 4 indicates how many times the base 3 is a factor. So, when we say 3 times 3 times 3 times 3, it's like, I like to think of it as times itself. That repetition occurred 4 times, right? So then you can say 3 to the 4th power. Evaluate and say out loud, let's try this together, 5 to the 3rd, right? We can say 5 to the 3rd power, or we can say 5 cubed. So certain powers, like you can say squared, you can say cubed, so certain powers have other names. So for example, x to the 2nd power, you could also call that x squared. X to the 3rd power, you can call that x cubed. All right? And if we evaluate that, well, now we know if you say 5 to the 3rd power, now we know that means 5 times 5 times 5, which is 125, right? Because it tells us how many times, basically, that 3 tells us how many times to carry out that multiplication, right? How many factors of 5 exist in that expansion. So 5 times 5 times 5 is 125. Sorry, the pen's being a little fussy there. I'll try to work on my handwriting. Helpful hint. This is just reminders before we do any heavy-duty math, that anything to the 1st power equals itself. So a to the 1st power equals a. All right, so 7 to the 1st power equals 7. 132 to the 1st power equals 132. A million, here we go, there's a million. A million to the 1st power equals a million, right? So anything to the 1st power equals itself. All right, so those are some basics. I just wanted to make sure you had the language under control, the base, the exponent, and what it indicates. Now let's talk order of operations. Some people say PEMDAS. This is an acronym. I want to remind you, this is an acronym. They say, please excuse my dear Aunt Sally. PEMDAS is an acronym for order of operations, and it reminds you to do the parentheses first, or grouping symbols, or brackets, any kind of grouping symbols, and then take care of your exponents. And then when you see operation multiplication or division, you move left to right over multiplication or division, and you move left to right over addition or subtraction. But the main gist is that multiplication and division dominate addition and subtraction, meaning must be done first. So this will make more sense as we go on. I have this recipe snipped in here for you. It really just says what I just said, that you evaluate any brackets or grouping symbols first, or parentheses first, and then you evaluate any exponents, multiply or divide left to right, add or subtract left to right. Everybody loves PEMDAS because it's a nice little acronym that reminds you of the order of ops. So let's dive right into this example. I'm going to write it larger. 3 cubed divided by 9 dot 2, meaning times 2, plus paren 15 minus 8 paren squared minus 3. Okay, so according to order of operations, according to, please excuse my dear Aunt Sally, you want to take care of your parentheses first. All right, so in here, so, 15 minus 8 is 7. Record. See what, and the big thing is, I want you to practice, even though you could do a lot of this in your head, practice writing step by step and line by line. Then we take care of our exponents next. Okay, so 3 cubed is 27. And let me just actually, I want to scoot this next example down. We're going to do another one together, but I want to give us enough room. Okay, so 27 divided by 9. Notice I'm just going to keep recording everything, but 7 squared, I'm going to take care of that exponent. 7 squared is 49 minus 3. Okay. Now, PEMDAS, I always remind myself, PEMDAS says to take care of any multiplication and division before addition and subtraction. But notice here, you multiply or divide left to right. So I'm going to write here left to right. So, don't get misled here. Don't think that you have to multiply. It doesn't mean that you have to multiply before you divide. It means you travel left to right over those operations. So when we see here division and multiplication, we're actually going to move left to right over that bit of information. So ready? 27 divided by 9 is 3.2. Okay, I'm just going to record that. Times 2 plus 49 minus 3. Then take care of that multiplication. 3 times 2 is 6. Then plus 49 minus 3. And then 6 plus 49 will bring us to what? 55. So remember, when we're at the end here, addition and subtraction, again, now we can just move left to right. So long story short, when you boil it down to just addition and subtraction, note to self, now just go left to right. Okay? So 6 plus 49, 55, minus 3, and voila. We say voila. What do we have? 52. So if you tried that problem on your own, maybe you hit pause and you tried it on your own, maybe you arrived at 52. Okay, let's try another one. Maybe you even want to hit pause and try this one on your own. I'm going to expand it here a little bit. Okay? All right, so PEMDAS says to go do... I'm always going to write PEMDAS over here on the side. It says to go and do your parentheses or your brackets first. Well, you always want to go in the innermost set of parentheses first and work outward. So 7 minus 5 is 2. Record the 4, record the minus, See how I'm practicing recording every little thing. Even though I could do some of this in my head, I'm recording every little step, which is important in algebra. All right. Keep working. PEMDAS says to keep working inside those parentheses, inside those brackets, any kind of grouping symbols. But you say, 13 is connected by 4 to 4 with subtraction, but 4 is connected to 2 with multiplication. Aha! And multiplication dominates subtraction. It's got to be done first. See? So we actually have to take care of this 4 times 2 business first. So 4 times 2 is 8. Record the minus, record the 13. See that? PEMDAS order of operations takes practice. Oops, I just realized. Exponents. We can take care of that now since it's at the end. 4 squared, I was going to say. Take care of 4 squared. We can take care of that a while. 4 squared, 16. Or we can wait until we're done cleaning inside of these parentheses. Okay? Style-wise, you could sort of do that simultaneously. Okay, so 13 minus 8 is 5, right? Record. Still recording those brackets, right? And, you know 4 squared is 16, so I'm just going to write that down a while. All right. And then we still have one set of brackets, but how are 9 and 5 connected with each other? By multiplication. So we can take care of multiplication. 9 times 5 is 45. And now look at that. We have the whole thing boiled down to addition, and we can just move left to right. So, 8 plus 45 is 53. Plus 16 is going to lead us to what? 69. Okay, so maybe you tried that on your own, but there's something I wanted to show you. Notice that deductive, notice it's almost triangular. We start and we boil something down to, to the final answer of 69. So notice that sort of triangular pattern. That's why I want you to get really used to writing down all your steps, bit by bit, phase by phase. All right. Hope that helps. Let's see if we have any other goodies. Nope. So that was our last example for the guided notes on order of operations. I really encourage you to find a bunch of these problems in the book or online, and just make sure you're solid. Okay, good luck out there.